Welcome. Today we'll learn the method to convert the NFA to DFA, NFA into the DFA. Okay. So firstly, the procedure is NFA to DFA. Let MN is a machine for NFA. QN is a states on NFA. Delta transition for NFA, Q0 and the final states of NFA. Okay. So here L means NFA. Be a NFA and accepts the language L of MN. MN is a machine for the NFA. And they should be equivalent DFA. It should be equivalent. Equivalent means what? Both the machines should accept the same language L. Means the language whatever it is given, that should be accepted by both the NFA and the DFA. Okay. And it should be equivalent DFA. So here all the things will be represented by D. So machine for D, machine for DFA, states for DFA, transaction in DFA, and final state of the DFA. Okay, so there are some 4 steps in this one. Step 1. So starting state of both the NFA and DFA should be the same. So normally it will be Q0. It can be different in some problems, but normally Q0 it is. And identify the alphabets of DFA. So almost in both NFA and DFA there will be same alphabets. Okay. And identify the transaction. So whenever we are considering the transaction for each state in the QD and for each input symbol A in sigma, the transition can be obtained by. So here for the transaction it has to check for both the symbols A and B. Okay, so first it will check the transaction for QI comma A. So QI comma A union. This is transaction taken in the NFA. Union again next state for the same input. Union again transition on the next state for the same input. Like that for every input you have to take the, means every state with a particular input you have to check the transaction. If it is moving to some state, you will write the state, otherwise you will write the file. Okay, this is how you will find the transaction. And if that answer whatever you will get after finding the union of all the transactions, that is not there in the states which is already defined in QD, then you will add that state into the states in the QD. Okay, and also you will add the same into the transaction also. Fine. And this step, the step 3 will be repeating till all the states will be added into the QD. Okay, then last step 4, identify the final states of DFA. Okay, so whatever the state in QD, if it contains the final state of NFA, means it can have any possibilities of states, but it contains the same final state which is there in NFA. Okay, then all those states will be considered as a final state in the DFA. Okay, so these points you will come to know when we are solving the problem. So this problem I have already solved, but it was with like 0 1 and 0 1, like that it was the problem. It is there in the series. Now we'll learn some other problem, that is obtain the NFA to accept strings of A's and B's ending with AB or BA. Okay, they just gave the question. First we have to design a NFA, then we have to find the equivalent DFA. So ending with AB or BA, and it should ending with, so beginning it may have any occurrence of A and B. Okay, so this is our minimum NFA for the given problem. So this is our NFA which is having 2 final states, 1 starting state. Okay, so for this one we will define the NFA first. QN, so this is all you have to mention, like NNN. Okay, and Q0 will be same for both the NFA and the DFA. Okay, so now QN, the first states in the NFA, Q0, Q1, Q2, Q3, Q4. This is your machine N. Okay, transition diagram for the machine N. Sigma is alphabet symbols. Q0 is the starting state, starts with the arrow. F is a final state. We have 2 final state, Q0 and Q4, and delta transition function represented by the table. Now Q0 for A, it is taking transition for Q0 and q1. So q0 q1 you have to represent like a set. Fine. Then q0 for b also itself and q3. So itself and q3 represented by a set. Then q1 it is q1 for a there is no transaction, so it is 5, and q1 for b it is q2. Okay, and q2 there is no transaction, so both 5, and it is represented by a star because it is a accepting state, represented by double circle. Okay, and q3 is having only one transaction, that is a for q4, and there is no for b, so 5, and q4 is a accepting state and is having no transaction for both the input symbol. Okay, now step one by one will go on. So first step, identify the start states of DFA. Starting state of both the NFA and DFA should be same. So here Mn, since Q0 is the starting state, so Q0 only you will be writing here. So that is a one state added into our QD. Okay, Q0 is a fixed state. Now next transaction. Next step, identify the alphabets of DFA. We have A and B as the alphabet. So same thing will be applied here. And identify the transaction of the DFA. Okay, so always have a transaction or the machine starts from the starting state. So Q0 only we have to start with the input symbol A. Okay, so here first transaction for the input symbol A from the starting state Q0, you have to represent like this. Transaction function for the DFA Q0 comma A. Now Q0 comma A where it is taking transaction. So Q0 for A it is Q0 or Q1. Both the way you can see here also or in the transaction table. Okay. So I will prefer this one because it is a correctly will get. Will not miss any data once we have written this one. So Q0 Q1. So Q0 Q1. Okay. This is our next state. You can mark it as 2. Fine. Now again for the symbol B from the Q0. B Q0 for B, Q0 Q3. So Q0 Q3, this is our state 3. Okay, now for the state 2, you can consider Q0 Q1. This is our state 2. For the input symbol A, we have to see. So transaction function Q0 Q1. Okay, Q0 Q1 for A. Now you have to split it out, this one. Okay, that is transaction function on NFA Q0 Q1 comma A. So that is how to split transaction function Q0 comma A. Each state you have to split it out. Union Q transaction function n delta n into Q1 comma A. Just we are splitting Q1 comma A, Q1 comma A and Q0 comma A. Okay. Now Q0 comma A we already calculated Q0 comma A, that is Q0 Q1, that you can write, and Q1 comma A. Q1 for 8 it is 5. So 5 anything union 5 also it will come that part only. So Q0 Q1. Okay, this is your state 2. You can mark it as 2 only because it is repeating. Okay, then for the same state again we have to give the input symbol B and we have to check the transaction. So again Q0 Q1 for B, Q0 Q1 for B, split the transaction Q0 comma B, Q1 comma B for the transaction function N and U. Okay, Q0 for B. Q0 for B it is Q0 Q3. So Q0 Q3 union Q1 comma B. Q1 for B it is Q2. So Q2. So now just order the states Q0, Q1, Q2 and Q3. Okay, Q0, Q2, Q3. This is a different answer. You mark it as a 4. Okay. Now for 2 both the input symbol over. Now we have a 3 Q0 Q3. So Q0 Q3 will consider as a new state and will give both the input symbol and will check the answer. So here you can see both the input symbol Q0 Q3 for A, split the answer. Q0 for A it is Q0 Q1 and Q3 for A it is Q4. Q3 for A it is Q4 and Q0 for A it is Q0 Q1. Okay, this is a new state, so you mark it as a 5th state. Fine. Next, now for A over, for B we have to find Q0 Q3 for B. Okay, same state, just we are giving both the input symbol A and B. Okay, now same way split it, find out Q0 comma B. Q0 comma B, what is the answer? Q0 Q3 and Q3B it is not taking transaction. Q3 for B there is no transaction, and Q0 for B it is Q0 Q1. So that is a Q0 Q3, Q0 Q3 for B. So Q0 Q3 it is a repeating state. This is 3. Okay, so 3 is a repeating state, so leave it off. Now similarly next one, which is a new state, we got fourth state, Q0 Q2 Q3. Okay, so Q0 Q2 Q3, if you split and do for both the states, you will get this answer. This is a fifth state and this is a third state. Okay, the fifth state Q0 Q1 Q4, third state is Q0 Q3. Now which is a new state in this? This is a new state, fifth state. So fifth state Q0 Q1 Q4, give the input symbol A and B and find the states. Now Q0 Q1 it is our first answer, that is a state 2, and Q0 Q2 Q3 that is our fourth state. Okay, so now we have 5 states, so those 5 states will write. Okay, so first one is Q0, starting state is our Q0, so Q0. Next one Q0 Q1, that is Q0 Q1. Next one, third one is Q0 Q3. Okay, and fourth one is Q0 Q2 Q3, and fifth one is Q0 Q1 Q4. Like that all the states you will write, and when you have to write the star, so whichever the function which contains Q2 and Q4, so Q2 and Q4 wherever it is there, okay, wherever it is there, that is your transaction, means the final state. So Q2 is this one, so this is a final state. This is wrong, it should be this one. Q4 it is here. Okay, since here we have Q2 and Q4 as a final state, so Q2 and Q4 wherever it is there, Q2 is here and Q4 is there, so these two states will consider as our final state. Okay, and all the transaction we have to write, means like Q0 for A, Q0 Q1, Q0 for B, Q0 Q3, A, Q0 Q1, B, Q0 Q3. So like that you have to fill the answers. I'll say one more, Q0 Q3. Q0 Q3 it is Q0 Q1 Q4 for A and Q0 Q3 for B. So like that you have to fill whole table. Now we are just equivalenting the state, means here whatever the state's answers is there, no, that we are just replacing with the Q0, Q1, Q2, Q3 and Q4 in order. Okay, so this order you can make however you want, or it better to make a same order, means just give the order of whichever order we are assigning here, no, that also that way also you can give. Okay, so here the order is a little different. They consider this as a Q2, means what, this as a Q2 and this as a Q3, so that they will make a same pattern. Fine, so DFA now. Q0 for A, Q0 for A, so what is the transaction? Q0 for A, Q0 Q1, Q0 Q1 means Q1 only, so Q1. Okay, and Q0 for B it is Q0 Q3, Q0 Q3 means Q3 for B. So like that you have to replace the transaction function, or you can make one more transaction function like Q0 Q1 Q2 Q3 Q4 for the same these transactions. Okay, so just to make it easy to draw, now Q0 for A it is Q1, Q0 for A it is Q1, Q0 Q1 means assigned to Q1, right, so Q1. Then Q0 for B it is Q0 Q3, that is Q3. Like that also you can make a table and you can easily draw this transaction table. Okay, so here you can see here Q2 and Q4 they made as a final state, so Q0 Q2 Q3, so Q0 Q2 Q3 is a final state and Q4 is this one, Q0 Q1 Q4 is a final state. So this is a wrong in the textbook. Okay, so these two are the final states, which is having the final states of NFA. Fine, this is the whole problem answer. for the NFA. I hope all of you have understood the problem. If you have a doubt, let me know.